Yes, thank you guys for all coming to this presentation. Like Ledger said, we are the USA Made Drone Team.
My name is Bryce Nunn.
I'm Connor Mattis. My name's Dayton Downing.
I'm Ryan Russell.
So to start things off, we want to thank our project sponsor. Our sponsor is the South Dakota Space Grant Consortium, and they annually provide about 240 grand to with scholarships or fellowships, and then also 130 grand in projects like our own today.
I'm kind of go into why we want to do this project. So right now there's a Chinese company named DJI, and they pretty much dominate the drone market. They have about 70 to 90% share on that. And then in this next month here, there's going to be a power ban, and that's going to prohibit federal agencies from using foreign-made drones or using foreign-made components for all federal contracts. And that opens the door for having a USA-made drone, and that's kind of why we're pushing toward this. And there are a couple U.S. manufacturers who are already trying to do this, and one is Skydio, and they are using these NDA compliant alternatives, which is something that Ryan will get into in a minute. And that is, a very popular drone. They kind of integrate some AI. Then, you can kind of see an effect from the ban already, or just fear of the future ban you're coming up as DJIs that never before. They had delayed release in.
Yes, Bryce just brought it up, but what does NDAA compliant actually mean? NDAA stands for the National Defense Authorization Command. In essence, it's just a list of components and parts that the government, specifically the Department of Defense, is. And leading back into some of the motivation for the project, if you look at this picture here, this website, it's Rotor Riot. They produce a lot of parts that regular consumers can buy and build their own drones. They have a specific NDAA tab. And then if you kind of look at other websites that are similar to Rotor Riot, a lot of them are like quickly implementing this tab. And, NDAA has become a really big word because the way the political world has been, they're really pushing for USA-made parts, USA-made components. So if these companies actually want to sell parts, they're racing to get this NDAA. And it's just kind of becoming a really big deal for our industry. And then leading from there, Blue UAS is, best way I can describe it, it's the next step up from NDAA compliant. And how that works is the DIU, the Defense Innovation Unit. They'll do like extra steps specifically for drones or UAS parts. They'll do supply chain verification of these parts. They do flight testing, and then they'll also audit these specific companies if they want this. And then before I get into this, I'd like to say, so we really wanted to get a good scope of the project, so we didn't waste any of our time. So we completed about 20-ish interviews to various people and businesses, industry. And then also talking with our design committee members, we got the scope down to develop a foldable, lightweight, and 4-pound range drone with AI capabilities that has U.S. manufactured components, which are U.S. And then all these key features of the drone really boil down to a reliable and really intuitive drone that people and businesses like.
Now we'll move on to our project scope. So our mandatory goals are, like we've been talking about, to have USA made components. So that's number one to us. But if we can't find that, then we move to the NDAA list or the Blue UAS list to find our parts. Then we'd also like to do some sort of AI task. Then we want to follow all the FAA regulations and have a foldable design so it's easy to transport and easy to move around with. Then our stretch goal is to have an autonomous charging station. So we have an idea, actually. There was a senior design project a couple of years ago that had a drone battery swapping station, and that was also autonomous. So if we get to this point in our project, we would like to reach out to them and see if we can integrate their system into our drone.
So AI has been a really big buzzword lately, and we'd like to clarify and be very specific about what our actual objectives are with AI on this drone. So jumping into a little bit of background, computer vision is probably the most widely used machine learning technology in robotics. And that process looks like training a model on thousands, millions of images. And then from those images, that model is able to detect and actually label images on whatever input you give it. And that's in a format that's readable to people. So this is maybe a more advanced example than what we would be doing. But as you can see from this picture of the street, it's able to pick out people, handmade cars, trucks, buses, traffic lights, and it's able to accurately label all of those. So using that technology, some of which is open source, we would be able to add algorithms and help make decisions based on the mission we put forward. So there's actually an example of this by this gentleman on YouTube. He built his own custom drone using the same Jetson computer that we were using. And he had that open source computer vision software. It would track him and then based on the distance from him, follow him around the field as he ran around. So that technology does exist. And some implementations that we've thought of, we came up with 3 specific examples, but this is a wide use case. Skydio, like we mentioned, they're making very expensive drones for military contracts already using some of the same technologies. But 3 examples we came up with is one that farmers can send the autonomous drone to count the cattle in their fields. I know a few farmers, and I know if they could save some time and not have to drive their four-wheeler around and spend time on more important things and get some peace of mind from autonomously counting their cattle, they would really enjoy that. Another example is for security teams at a packed venue or a concert. So security teams are overworked already, but if this drone can scan the crowd and look for people running around with, backpacks and a ski mask, it can highlight that person, and then the security team can decide how they want to react to that individual. And then a third application we're pretty excited about is for both GPS and communication denial zones. So that's a major application for military use. You could have your Navy SEALs pull out this drone and monitor their entire operation fully autonomously without needing communication with a controller or GPS. Another big aspect of our project is the foldable design. That's something from our interviews we learned that almost every person is going to want from a commercial drone. So 2 examples on this illustrative CAD model that I'd like to point out. So like Dayton had mentioned, we are interested in integrating that autonomous battery swapping system. So we already implemented sliding battery rails for our full battery system, and that's going to make that integration a little bit easier if we reach that stretch goal. And then we've also designed a 2 degree of freedom joint, which I actually have an example of. So this would be the leg of the drone, and it's both able to pivot and then tilt underneath the drone. So I'll show you what this would look like with an example of DJI's Mavic 4 Pro. So like we mentioned, DJI is the major player right now in the drone industry, and their back arms, as you watch, actually fold up and under, which helps keep it more compact without having to offset the 2 arms as much as some other companies are doing right now. So we wanted to adopt a similar approach in our folding design. I've kind of laid out the steps of how this drone would fold, but those front 2 arms are going to fold directly along the sides, while the back 2 first fold up, and then they pivot underneath the body of the drone. And maybe the best way to see that is on that 4th picture where the props are actually facing downwards, because now you've folded the arm completely under. All right, I'm going to jump a little bit into our block diagram. So starting on your left, we chose a 6S lithium ion battery, lithium ion for a little bit better energy density, and then also 6S to power our motors. That's going to work through a power module to power both our 4-in-1 ESC, which we selected because it has the capability to supply current to all our motors, and it's a little bit easier to integrate because it's 4-in-1 instead of 4 ESCs on each arm of the drone. We have 5-volt power rail connecting to our top brains of the system, is what I would call it. And I'll jump into that just in a second. All 4 of our motors are at the bottom, as you can see, and we have a separate power rail that powers our gimbal. That gimbal is going to hold the digital camera stable, and that digital camera feed actually goes straight to our NVIDIA Jetson, which is that computer that's capable of the machine learning on. And we also found that we can actually compress that video feed and then send it over 2-way telemetry radio straight to our ground control station, where you would be able to view the camera feed and then also plan your mission based on GPS and that image using that cube run. A couple other features on here, we are planning to purchase a GPS, a collision avoidance sensor array, and then radio transmitters, because right now there isn't autonomous flight available. You have to use manual control for the most part. So we'll have that manual controller as well. And then the top of the brain I mentioned, we found from this company called ARC, they're a fully US-made NDAA compliant company, and they have a fully integrated board that combines both their state-of-the-art flight controller and an NVIDIA Jetson, which enables that machine learning. So that's all integrated into a single circuit board that all our sensors.
Now, as we did research for our USA parts, we found the perfect motor through this e-propelled US company, but they're not releasing the motor till around March or April. So we decided to have a proof of concept motor through Hobbywing. Now, Hobbywing is a Chinese company, but we were able to find almost the exact same motor, and we'll use that as a proof of motor concept until this USA made e-propelled motor is released.
So I'll get into some design scene matrices for our performance. I know Connor brought it up earlier, but we're gonna specifically go with the foreign one, make it a little bit easier to integrate for us. The most important one for ESC will be the current ratings. You know, the moderate range for us, just because our motors don't have that much drop, works out pretty well for us. And we got some other tiebreakers down here, especially price, since we're working on a little bit of budget. We're gonna end up going with the R401 ESC. Now for the GPS systems and navigation. I know you guys might see a lot of ARC products down here. Surprisingly enough, we don't really have that many options to choose from as of now for GPS systems. The most important one would be accuracy, precision. And then we got a couple. We ended up having the same exact score, so we went with a tiebreaker for update rate, just so our ground control system will have a lot more accuracy there. And then some other miscellaneous items that go into that. And then finally for the receiver, the most important one for us is price, just because a lot of these are really similar with their actual values. And another one I'd like to bring up is I know the antenna number. We only really have two options, so it's a little bit harder to throw that into the weight aspect, but 2 is definitely better. And because of that, we're going with the nano average speed, 950.
I just kind of want to show you what we've done this year pretty much and our future schedule here. So our big things are our systems definition review and then our preliminary design review, which we just completed last week. So we're on a little different schedule than most people. But those are just meeting with our sponsor and our design review members just to kind of make sure we're on pace for finishing our project and make sure we have a good goal and stuff. And then we hope to, at the start of next semester, get our CAD models done and also do our critical design review. And that's pretty much just basing if the sponsor wants to go ahead and move forward, continue with this project, is it worth it? Can we need a budget, right? So yeah, we hope to have our CAD models done for that since we only have like a week of actually working on that. And then here's kind of how our budget is right now with about 25% plus or minus. So in the green, that's all stuff that we're pretty certain on the pricing. So we're almost at $4,000 right there. And I mean the major portion is the control, which is the ESC receiver transmitters, flight controller, and we've got some packaging that's a huge portion of it. Then we just put in kind of $200 assumption for the electrical controllers, just like fuses and additional wiring. Then for our frame, our carbon fiber plate, if you're looking at any plan on doing a lot of 3D printing to try and lower that cost and weight of it. And then our motors that about $80 for the Hobbywing motors combined, and then the e-propelled took an assumption of about $200, so or per motor. So that's a huge difference there. And then our temperature and GPS. So here's kind of just a breakdown of the sub-assemblies. But the huge portion that you can see is the controls portion. And then the motors is almost 100%. Then as a breakdown in weight, we're assuming on the high end for the frame, we put 500 grams. And then that's a huge portion, plus the battery is a major part of the power delivery system. So those are adding up to a regular weight. And those are, I mean, the battery is pretty confirmed. And then, we get a total weight of 3.5. Any questions?
So kind of a two-part question going back to your autonomy and your machine learning. So a big one I thought was the cow counting. So obviously you're going to be implementing an AI vision system. Are you also thinking about doing some sort of GPS, or will it be manually operated? And then how do you plan on developing that in parallel with your drone? Because I would maybe be worried about spending the entire semester developing your drone and then running out of time at the end of the year to train and apply your model.
Yeah, so I maybe should have clarified this when I was on that slide, but all we're planning to actually deliver at the end of the semester is one demonstration task. So we're gonna do some training with that model, but that's gonna be a smaller portion of the project besides delivering the actual, fully capable drone. Our task that we've come up with is similar to the video I showed. So a drone maybe following someone or counting people in a crowd. That's something we're gonna have to narrow in a little bit closer on once we get used to the software using the Jetson, but.
Yeah, so I guess kind of with your question, this may be a little out of scope, but we've seen examples like the kid at the high school whose bag of Doritos got confused for a gun. Do you guys have some sort of fail safe or misinputs like that? Especially more on like the security side, like you said, a guy with a ski mask and a backpack versus a mom wearing religious headgear and a backpack full of her baby's diapers.
Yeah, I guess the drone itself wouldn't really be acting on the information. It's going to be highlighting that for the security team. So I would assume that they would look more carefully. I would hope that they would look more carefully and ensure that there actually is a threat before they. But
How much is a Mavic 4 Pro, or the one you had for comparison?
so the Mavic 3 Pro is a little over 2,000. The Mavic 4 Pro is a little bit higher. I'm trying to remember the exact price. It's around 2,000.
Okay. And
Other
then,
than USA made drones are running around 22,000.
okay.
Yeah, at least the Skydio model, that's
Yeah.
kind of similar. to
Basically the same drone, 10 times.
Yeah, that's why I'm kind of through those, that order comparison in there, because it's basically the same thing as price, just all.
And how confident is that assumed motor price?
I mean, we were basing it pretty much off their website because we actually like put in a request for like a motor or for them to design motor, and then they said they actually do have something in already that's what we did ask for. So I mean, it's not super certain, but like on their lower end of motors for their like ones for 5-inch props were only $70-80 I think per motor, versus once you got up to the 9 to 11-inch props that they're recommending for the motor, it was like $220. So we're showing yes, and high yes, better safe than sorry.
I know you mentioned you want to use the, I think it was 2 years ago, senior design project with the battery swapping. Do you have any worries of it being a different battery, or is it, do you know what type of battery they used?
Don't know what type of battery they use quite yet. We haven't reached out to them, but once we get to that portion of our project, if we get to that portion of our project, then yeah, we reach out to the team members from that team, figure things out.
Are you guys going to have any issues with 100% domestically sourcing this thing?
Yeah, we already have basically, but and a lot of parts have been coming out. So I mean, give it a year, I'm sure it'll be a lot easier. But yeah, as of now, that's why we're really highlighting NDAA and Blue UNS.
Yeah, we did put kind of an objective of hopefully doing over 80% cost, which I think we're gonna hit easily, because the only part that we're like, I think for certain we can't get NDA compliant or Blue US is the Google. So we might have to source that.
I guess I have one too. You kind of glossed over this today, but what's the plan for collision avoidance sensors?
Yeah, so we have a few different ideas. That's something we're still working on, but the implementation that DJI uses is actually optical sensors. They just have cheap cameras at each corner of the drone, and they feed that through their NVIDIA Jetson. So we could go that route with machine learning as well. We could use just our main camera for collision avoidance. Also common is LiDAR, but that's a little bit out of our price range. So most likely optical sensors or laser sensors that we found for laser range finding.
Okay.
Options as well.
Did you think about ultrasound?
We're not at all interested.
I think that's a little budget for us to just.
Any other questions from the audience?